IIT-Madras and General Electric tie up to build the next-gen combustor for small aircraft and helicopter engines. Chennai, IIT-Madras and General Electric India Technology Centre are jointly developing a 3D-printed combustor aimed at reducing weight and improving fuel efficiency in small aircraft and helicopter engines. Both organizations are designing the combustor, the burner in a gas turbine engine, with nearly 1/10 of the parts as compared to traditional engines. The R7.24 crore Rajhatar Yojana (UAY) project is being carried out by the Aerospace Department at the Institute and is being funded by the Government of India, 75% and 25%. The fabricated combustor has only 4 parts, whereas the same combustor, with conventional manufacturing, will have at least 30 parts, said Professor S.R. Chakravarthi, faculty in charge, National Center for Combustion Research, and CCRD at IIT-Madras. The primary objective of this project is to reduce the length of the combustor, which will reduce its weight. It also reduces the fuel consumption of the engine, he said. The engine could also be used in power generation. In larger aircraft, it could be used as part of an auxiliary power unit, APU, as well as for distributed, decentralized power generation as in backup gensets, or in remote locations, or along with hybrid solar, wind smart grid solutions. While there have been several improved combustors designs recently, this project aims to further improve these metrics with a design that uses additive manufacturing technology and non-intrusive laser diagnostics. The project team has successfully completed testing 3 8-cup full-annular combustor configurations. The results show the feasibility of 30% reduction in length of a conventional rich burn combustor. Currently, the team is focusing on the optical diagnostics experiments where laser diagnostics tools are being used to understand the flow physics inside the combustor. These results will help optimize the performance and to probe any further possibilities of length reduction, the professor said. The size and weight of the engine would be the same depending upon how the combustor is designed to fit into the rest of the engine. The weight savings, however, will be on the raw material of fabrication in additive manufacturing. This could lead to a substantial drop in weight, as much as 50% when compared to conventional combustors. Further, Dr. Chakravarthi said the additive manufacturing of the combustors which were tested for this project were outsourced to Indian suppliers. These suppliers, he said, were now capable of adapting additive techniques for geometries as complex as combustor domes and liner, which in turn would help in developing the country's additive manufacturing infrastructure. A special feature of this project is that it marks the first time that a 3D-printed full-annular combustor was tested at actual turbine conditions in India. The lab, which is housed in the National Center for Combustion Research and Development, and CCRD, at IITM also boasts of being the first in India to have a high-pressure optically accessible combustor test triggering state-of-the-art laser diagnostics tools under one roof. IITM has an IP rights share with and expects to immediately use this in their product. Going forward, Dr. Chakravarthi said that if IIT is not absorbing the technology, for whatever reason, they have the first right of refusal after a lock-in period for IITM to commercialize the IP. Commercialization will be in the form of licensing to similar such engine houses as IIT or to a startup to develop a product that could be incubated by IITM itself.